All right. One last example. Let's look at a situational problem here. So a small business sells handmade candles. The cost to produce X candles in a single day is represented by the linear function C of X equals 0.5x plus 400. The business sells each candle for $3. Write the function representing the revenue, R of X for candles sold. Write the function representing the profit of selling X candles. So let's do one thing at a time. The business sells each candle for $3. Write the function representing the revenue. So I want to find how to call this R of X. So the revenue is, again, how much money I'm earning per thing sold, for each thing sold. So I'm selling them for $3. So this is $3 per one candle. And I'm selling X candles. Again, these two units cancel. And I'm left with $3. Well, the only unit left is $3, and 3x represents the revenue. Okay, that's straightforward, I think. All right, so we got this done. Write a function representing the profit for selling X candles in a given day. All right, so profit. Profit means revenues minus cost. So profit is equal to revenue minus the cost of producing each item. So in this case, what I want is R of X minus C of X. So what's my revenue? Well, the revenue I figured out right here is just going to be 3x. Then I'm subtract the cost function, which is sitting up here. And again, notice the cost function consists of two components. So because of that, I need to put parentheses. Again, it is not correct unless you need parentheses. So again, just to emphasize that parentheses are not optional. Okay, so keep that in mind. And now I'm going to come over here and just clean this up a little bit. Subtract 0.5x. Subtract the 400. And I get 2.5. Again, these are like terms. 3x minus 0.5x is 2.5x. And there is my profit. Okay. Lastly, write the function representing the average cost of producing X candles per day. So the cost is sitting right here, and notice that it costs 50 cents of maybe material and labor to produce each candle. And the worst, what about the 400? Well, maybe this is a cost. Even if you produce no candles, there's still this fixed cost. Maybe this is insurance. Maybe this is rent on a building, paying for your whatever. So there's things that even if you produce nothing, you still have to be paying no matter what. So that's where that fixed cost comes in. And now, obviously, the more candles we sell, the overall cost of producing candles will go down. In other words, this is if this wasn't here, then this would be the average cost is 50 cents per candle. But it's this fixed cost that we are now dealing with. So what is the average cost, which I'm also using two letters for average cost to produce X candles. Again, it's an average, so how do you calculate an average? So it's just going to be the cost divided by X. So in this case, I'm going to be 0.5x plus 400 divided by X candles. So this will be my average cost. I could leave it this way, or I can reduce it. It's not going to look any prettier reduced, but it sort of does hint at something else. So again, when I divide, I notice I'm using a distributive property here, meaning I'm dividing this term by x, dividing that term. So this is the division version of distribution. These X's representing the candles. Cancel. And I'm left with 400 divided by X. So notice what this is saying is that the average cost, definitely per candle, is just the 50 cents every time I produce one. However, added to that is I need to take into account there's a fixed cost and I divide that by X. So really, you can see even by this equation that we have written, the issue is this fixed cost for 400. The more candles are produced, the average cost will go down. This is the program Desmos, and it might be always a good idea to graph just to see what's happening. So you need to do things algebraically. So I'm going to just enter the last function that we played with. As a matter of fact, I'm going to write it using function notation. I don't think this program allows me to write two variables as a name. I'm going to try it just for the heck of it. Yeah, it did. Okay. That's cool. No, it does not like that. Yeah, it only wants one letter. I'm going to go A for average. Okay, good. So that's not a problem. So great. Now this should have graphed, but you see that you see nothing. So I'm going to focus out a little bit, and now we started seeing the graph a little better. Okay. Now this one, of course, the average code doesn't allow you to enter a 0. But you can see that as you increase the number of candles, the cost goes down. So for example, if I produce 2 candles, the average cost per candle is $200.50. If I produce 20 candles, it's $20.50. You can see right here, this is the number of candles, and you can see that it's slightly above 20. If I produce 50 candles, then I'm going down to $2.10. So notice after a while, you can determine when is it profitable. Like it cost me, looks like what, 50 cents per candle to produce. So as long as I am above, no, how much does it cost? I'm selling these candles for $3. Okay, so as long as I am able to produce them for an average for less, I'm good. So I'm going to right here, y equals 3, and there's the line. And you can see that at 250, I'm definitely now ahead of the game. And we can always figure out, you can see right here is where they intersect. So in a day, I would need to sell 160 candles, because at 160 candles, the average cost is $3. Remember, I sell these things for $3 a piece. So that's how many candles I need to sell in order to break even.